Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from a very old paper from June 2006, the Edexcel Core Mathematics C4 paper, and this question is question number 5 about vectors. The question that the student asked me from this particular paper was, I think, part C, but just to make it complete, I'm going to do the 3 parts of the question, A, B, and C. So point A says the point A with coordinates 0, A, B lies on line L1, which has equation r equals 6i plus 19j minus k plus lambda times I plus 4j minus 2k. Find the values of a and b. So here we have the vector equation of a straight line, and the vector is made up of 2 components or 2 parts. Two vectors kind of like define the line. One of them is, and I'm going to write them as column vectors because I prefer that in my calculations, is the position vector of a point on the line. So 6, 19 and minus 1 is the position vector of a point on the line somewhere. And then you have plus lambda times, and then this other vector that you have, which is multiplied by the scalar parameter, is the direction that the line is moving in, which is 1, 4 and minus 2. So like this is the origin, for example. Say this is the line L1. This could be the point 6, 19 minus 1. So to get to the line, you have to go along that vector 6, 19 minus 1, and then the direction of the line is given by 1, 4 minus 2. So like that bit, that little part here might be one portion of 1, 4 minus 2. 1, 4 minus 2. So depending on how many lambdas you're going to have, if you have 0 lambdas, you'll be here. If you have 1 lambda, you'll be there. If you have 2 lambdas, you'll be there. So you have to add this and 2 times that to get to that point. So that is basically the vector equation of a straight line. Okay, so you have a point on the line and you have the direction of the line, kind of like y equals mx plus c for Cartesian equation of a straight line. The c part tells you a point on the line, which is in fact the y-intercept, and the m part tells you the gradient of the line, which is like what direction it's moving in. So it's kind of similar in that way. Anyway, so that's just a bit of background there. So what we're told is that there is a point line A, which has coordinates 0, A and B. So basically what we can say is that this will take us to the point 0, A and B for a particular value of lambda. As I mentioned, you go to the line, then you go along the line. There's going to be a point somewhere, the point A, which has those coordinates, and there will be a value of lambda that takes us to this point. We got to find what the coordinates of this point are. We're going to find what A and B are. We know the coordinate of the I coordinate. So if we look at the I components and the J components and the K components, from the I components we can make an equation 6 plus lambda equals 0, which means lambda is equal to negative 6. So I know the point A is is where lambda equals negative 6. So I can find the J component. If I look at the J component, I have 19 plus 4 lambda equals A. So A is going to be 19 plus 4 times negative 6, which is 19 minus 24, which is negative 5. And for the K component, so that means A equals negative 5. And for the K component, I'm going to have minus 1 minus 2 lambda is equal to B. So therefore B is equal to minus 1 minus 2 times minus 6, which is going to be minus 1 plus 12, which is going to be 11. So B is equal to 11. So we have our values of A, and we have our value of B. Okay, so that's the point A. We can write down, if you want to, the point A therefore has coordinates 0 and minus 5 and 11. Okay, but those are the answers to this question, and that answers part A. Alright, now for part B. It says the point P lies on line 1 and is such that O to P is perpendicular to line 1, where O is the origin. Find the position vector of point P. Okay, so now we have, just imagine this is line 1. Let me make it a bit thinner. Just imagine this is the line. And just imagine, I'm going to put it randomly anywhere, the origin is here. I know that the line that takes me, let me make it a bit further away to make it, in fact let me put it up here, give myself more space to work on. Now I know that there's a point on line 1 such that that point is the vector O to P will be perpendicular to line 1. So it's going to be somewhere over here. So if I put my O there, the P is going to be over here such that that's perpendicular. This is line 1 and this is the vector O to P. Okay, we know that they're perpendicular, right? Now we want to find the position vector of point P, which is going to be given by, let's call it x, y, z. X, y, z. We find that we'll find the position vector of B. So let's O to P, which means the position vector of point P. When it says find the position vector of P, it means find the vector from O to P. So let O to P be x, y, and z. Right. I know two things about the point P. Okay, I know that P lies on line 1. That's one piece of information that's going to help me find the coordinates of P. And 2, I know that the vector O to P is perpendicular to line 1. Okay, I know for sure that's also true. Alright, so now I can use those two pieces of information. The first piece of information I can use by understanding that line 1 has an equation, and I'm going to again write the column vector 6, 19 and minus 1 plus lambda times, but I'll make it a bit bigger so I want to get, let's put it down here a bit. Okay, so I know that I'll put this down here. I always like to use column vectors. It's way more efficient and easier to follow, neater. So 6, 19 minus 1 plus lambda times 1, 4, negative 2 definitely takes me to the point P, x, y, z. If O to P, if P lies on line 1, then there will definitely be a value of lambda that takes us to line 1. Okay, takes us to the point P. Alright, so we're going to have, this is going to form for us 3 equations. From this we can derive 3 equations. We can say that 6 plus lambda equals x. We can also say 19 plus 4 lambda is equal to y. And we can also say minus 1 minus 2 lambda is equal to z. Those 3 equations are going to help us. Now the second piece of information is that OP is perpendicular to L1. So I know that OP is equal to XYZ, and I know that the direction of line 1, we don't care about the position vector of it, we care about its direction. We're talking about perpendicular vectors, we care about their direction. So the direction of line 1 is given by just this part of the vector, 1, 4, minus 2, the part which is associated or multiplied by the scalar parameter. So what we know from our understanding of vectors is when you have two vectors which are perpendicular, then the dot product of those vectors is equal to 0 if they are perpendicular to each other. So we can say let A be XYZ and let B be 1, 4, minus 2. So I know therefore that XYZ multiplied by 1, 4, negative 2 is definitely going to give me 0. So we can make an equation from this as well. So x times 1, which is x, plus 4 times y, which is 4y, plus minus 2 times z, which is going to be minus 2z. Minus 2z is equal to 0. Always put a line through your z, otherwise you get confused with 2 sometimes. So now I can use these 3 equations, okay, and I can use these. So I know x is 6 plus lambda, so I can now replace x with 6 plus lambda. And I know y is 19 plus 4 lambda, so I have 4 times 19 plus 4 lambda. I know z is minus 1 minus 2 lambda, so I have minus 2 times minus 1 minus 2 lambda, and that's equal to 0. So I have 6 plus lambda plus, that's 4 times 10, 40, plus 36, that's 76, plus 16 lambda minus plus 2 plus 4 lambda equals 0. So let's put the like terms together. You have lambda plus 16 lambda plus 4 lambda, that's 21 lambda, and you have 6 plus 76, which is 82 plus 2, 84. Plus 84 equals 0. So 21 lambda equals negative 84. So lambda therefore is negative 84 over 21, which is equal to negative 4. So we know that, okay, the point P is where lambda equals negative 4. So we can take our, you can take this if you want even, or you can take these, we can say x, y, and z. So I know x is equal to 6 plus lambda. I know y is equal to 19 plus 4 lambda. 19 plus 4 lambda. And the z part is minus 1 minus 2 lambda. So this is going to be 6 minus 4, which is 2. And this is going to be 19 plus 4 times minus 4, which is 19 minus 16, which is 3. And you're going to have minus 1 minus 2 times minus 4, minus 1 plus 8, which is 7. So we can say the vector from O to P is 2, 3, 7. Now they want it in, it's better to write it in IJK form, 2i plus 3j plus 7k. In the end, write it in this form because that's how they gave us the question, in IJK form. So you should give your answers in the same form. I like to use column vectors for my working out because I find it makes everything more logical and easier to follow, and just a lot better. So in the end, if they ask you for the position vector, write it in this IJ form if the question gave you things in that form, which they did. Let's see, was that a problem here? No, that was just finding the values of A and B. That's not a problem. Okay. So now for part C, it says show that the points A, B, and P. So it's a given that B has coordinates 5, 15, and 1. Show that the points A, B, and P are collinear. Collinear. And find the ratio A to P to B, P to B. Okay, so now, when you have lines which are collinear, that means they're on the same straight line. So A, P, and B, if they're collinear, they would lie on the same line. Okay, that they would definitely lie on the same straight line. So how can I prove that points are collinear? So supposing this was A, supposing this is B, and supposing this is P. If A to P, okay, is parallel to A to B, if that's true, then we can say, therefore, we can say that they are in the same direction and therefore on the same line. Why? How can we say that? Because if they have this, if they're parallel, meaning they have the same direction, if the direction of A to B, A to B is the same direction as A to B, A to P and A to B have the same direction, and they're both, because they're both passing through the same point A, they must be on the same line because they have the same direction and they're passing through the same point. I could say the same thing for A to B if it's parallel to B to P. I could say the same thing. If A to B is the same direction as B to P, they both pass through the same point and they're both the same direction, therefore they must be collinear. They must share the same straight line. Okay, so I can choose which one I want to do. I want to, in the end, find the ratio of A to P to P to B. Alright, so what I'll do is I'll find the vector A to P and I'll find the vector P to B, and that will help me with that second part. So I'm going to find those two things. Okay, if I find those two things, that's going to help me. Alright, so how do I find the vector A to P? So everything is related to the origin. Say this is the origin. Okay, these are like almost like position vectors. I can say the vector from O to A is given by 0, minus 5, 11. So coordinates are kind of like position vectors in a way that you refer them to the origin always. And if the coordinates of P are 2, 3, 7, then O to P is 2, 3, 7, like this. And if the coordinates of B are 5, 15, and 1, then O to B is going to be 5, 15, and 1. Okay, so if I want to find, for example, A to P, that means I've got to go from A to O and then from O to P. Okay, that will be the vector A to P. Okay, just write P there. All right, so I've got to go from A to P, A to O plus O to P, which is the same as saying O to P minus O to A. Why? Because you're going minus OA plus OP. Okay, so I'll draw this way. So you go minus OA plus OP. Okay, so O to P, as we know, is 237, minus O to A, which is 0, and minus 5 and 11. And that's going to give me the vector A to P. So 2 minus 0 is 2, 3 plus 5 is 8, 7 minus 11 is negative 4. So here we have the vector A to P. So we have A to P is 2, 8, and negative 4. Now we're going to find the vector P to B. Okay, so if you want to go from P to B, we've got to go from P to O. We're going to go from P to O and then from O to B. Okay, so from P to B is going to be basically minus OP plus OB, or you can say OP minus OB. So OB minus OP. Okay, so you want to go minus OP plus OB, so OB minus OP. That will give you the vector that we're looking for. That's going to be given by 5, 15, 1, minus 2, 3, 7. That gives us 5 minus 2, which is 3, 15 minus 3, which is 12, 1 minus 7, which is minus 6. So we can see the vector from P to B is equal to 3 and 12 and negative 6. Now what we can do here, A to P, okay, what we can do here, let me just write this neater, 2, 8 and negative 4. What I'm going to do is I'm going to take the vector A to P and I'm going to factorize it. A to P can be written as 2 times 1, 4 minus 2. That's 2, 8 minus 4, right? Good. And P to B can be written as, if you take out the common factor, which is 3, you have 1, 4 and minus 2. So you can see that they are almost the same vector. Okay, they are almost the same vector. You can say, for example, A to P over 2 is equal to 1, 4 minus 2, and you can say P to B is equal to P to B over 3, sorry, is equal to 1, 4 minus 2. All right, so if that's the case, then we can say that A to P over 2 is the same as P to B over 3. Therefore, we can say A to P must be 2/3 of P to B. Okay, A to P must be 2/3 of P to B. So we can say now that as A to P is a multiple of P to B, therefore they have the same direction. Okay, that's one point. And then we can say as A to P and P to B both, okay, pass through the same point, which is P, therefore they must be collinear. They must be collinear. They must be on the same straight line. Okay, so that is the proof to show that they are collinear. You have to state, as it says here, you have to find the ratio of A to P to P to B. A to P to P to B. Now we know that A to P is 2/3 of P to B. So let's think about this. So A to P is 2/3 of P to B. Okay, so if that's A and that's B, so the length from A to B is 2/3 of the length of P to B. So it's going to be smaller than the length P to B. So that's P to B. This is 2/3 of that whole length. So we could say the whole length is 5. This is 3 parts and this is 2 parts. So A to P will be 2/3 of the length P to B. Okay, so we can say that the ratio of A to P and P to B is 2 to 3. 2 to 3, because A to P is 2/3 of the total of the length of P to B. So we could say that's 2 to the total length is that you can say the total parts is 5. A to P is 2/3 of that 5. Okay, that's what we could say. Right? So yeah. So A to P is 2/3 of P to B. Yeah, so that means A to P. It's not of A to B, it's A to P. So you got to be a bit careful about that. So A to P to B must be 2/3. I hope that's clear for you. Okay, because we know that this length here has to be shorter than that length. Okay, because it's 2/3 of that length. It's not 2/3 of the whole thing. Okay, we could say that if A to B was 5 units, then this is going to be 2 parts. That's going to take up 3 parts. And then A to P will be 2/3 of P to B. Okay, so that's how we can work that out. The total parts is 5. This takes 2 parts, that takes 3 parts basically. Okay, so there's the answer, for that question. We can think of A to B as the whole thing. Yeah, A to B is the whole thing. You could say that A to P is 2/5 of A to B, and P to B is 3/5 of A to B, and then we can say therefore A to P to B is going to be 2/3. Okay, so that's how we can work out that answer. So there's the answer to this question number 5, I think it was, part C. Question number 5, part C from this paper. I hope that was clear, that last bit. I just want to make sure that you do understand in case there's an issue. So let me just go over that again just a bit more clearly. Okay, just to make sure that you understand. All right, so we have a line. We know we have a point A. Okay, and we know that the length from A to P is 2/3 of the length from P to B. So if this is P, for example, A to P is smaller than, it's 2/3 of P to B. Okay, so this is like 2/3, okay, of this. Okay, this is say this is 2/3, and this length here is going to be, you can say, 2/3 of let's call that 2/3 to 1. 2/3 to 1. You can think of it like that if you want to. Now, if I want to make that into a simplest form, okay, I can just multiply both sides by 3. So I can say A to P to P to B. If you want to write it, if you want to think about it like this would be 2/3 and that would be 1. But we want to write a ratio in the simplest form, so we can multiply both sides by 3. That's going to give you 2 to 3. Maybe that's an easier way for you to think about it. The ratio of A to P to B is 2/3. This is 2/3 times that. Okay, so we can work it out. You can make it the ratio like that as well. That's an alternative way of thinking about it. Just want to make sure you understand properly. Okay, so that's the end of this question. Other questions from this paper, if I am ever asked to answer them, will be found in the playlist that I'm going to put a link for over there. Other questions dealing with vectors in general, you can find P4 vectors in this link over here. You can subscribe to my channel by clicking on this link, and you can watch a video up here which takes you or tells you how to use my channel effectively. Thank you for watching, and see you soon.